How do you move a stone heavier than a blue whale? Without wheels, cranes, steel, or engines, some of the blocks used in ancient Egypt weigh over 80 tons, and they were transported for miles. Raised position aligned with near millimeter precision. No modern machines. No advanced metal tools. So here's the real question. Were the ancient Egyptians more technologically advanced than we think, or are we underestimating human intelligence? Let's decode this mystery using science. The Great Pyramid of Giza contains about 2.3 million stone blocks. Most weigh between 2 and 15 tons, but some, especially granite beams inside the king's chamber, weigh up to 80 tons. And they came from quarries nearly 800 kilometers away in Aswan. That's not just construction. That's logistics. For centuries, people have asked, how did a Bronze Age civilization move stones that modern cranes struggle with? Some propose lost technology. Others suggest aliens. But archaeology tells a different story, and the real explanation might be even more impressive. Let's start with the most common assumption. They must have used slaves. That idea dominated textbooks for decades, but excavations near the pyramids uncovered workers' villages, graves, bread ovens. Medical tools. These weren't enslaved laborers. They were skilled workers, fed well, organized into teams. High confidence, based on direct archaeological evidence. So if not brute force slavery, then what? Moving 80 tons isn't just about strength. It's about friction. If you drag a 2-ton block across sand, it sinks. The force required skyrockets. Multiply that by 40. It becomes nearly impossible. Or so it seems, until 2014. Researchers recreated ancient sledges and tested them on desert sand, and discovered something surprising. When you slightly wet the sand, friction drops dramatically. Most sand forms tiny bridges between grains. It becomes firmer, more stable. Workers in tomb paintings are shown pouring liquid in front of sledges for decades. Historians assumed it was ceremonial. Physics says otherwise. High confidence, supported by experimental replication. Suddenly, the impossible becomes practical. But dragging stones across sand is only part of the story. How do you move 80 tons across 800 kilometers? The Nile. Satellite imaging and sediment analysis in 2020 to reveal the long-lost branch of the Nile, now dry up, that once flowed near the Giza Plateau. Researchers call it the Khufu branch. Boats could carry massive granite blocks downstream. River transport reduces friction dramatically compared to land hauling. High confidence, based on geological core samples and satellite data. The pyramids may have been positioned near water access that no longer exists today. We were asking the wrong question. They weren't hauling everything across desert. They were using a natural highway. Transportation explains horizontal movement. But how did they lift stones 100 meters high? Here's where debates begin. Several ramp theories exist. Straight ramp, zigzag ramps. Internal spiral ramps. Straight ramps would require an enormous material, possibly larger than the pyramid itself. Low to moderate confidence. Internal ramp theories suggest a hidden spiral inside the structure. Thermal scanning and tomography have detected internal voids, but none conclusively prove a spiral ramp. Moderate confidence. Most Egyptologists support a combination approach. Large external ramps for lower levels, smaller angled ramps as height increased. Plus leverage tools, wooden sledges, ropes, and counterweights. No advanced machinery. Just geometry. And manpower coordination. High confidence for ramp usage. Uncertain on exact configuration. In recent years, AI modeling has reconstructed labor logistics using known workforce sizes, about 20,000 to 30,000 seasonal workers. Simulations show, with rotating teams, lubricated sledges, river transport, and ramp systems, the Great Pyramid could realistically be built in about 20 to 27 years, which aligns with historical records of Pharaoh Khufu's reign. I doesn't prove the exact method, but it proves feasibility. And that matters. High confidence in logistical plausibility. Then BNN wet sand reduces friction. Significant river transport was heavily used. Skilled labor forces lived near ramp systems were used. Copper tools and dolerite pounding stones shaped granite mkshne. Internal ramp hypothesis specific ramped, geometry exact workforce numbers. Anti-gravity technology sonic levitational and intervention lowest advanced civilization sure. Zero credible archaeological evidence for advanced, unknown technology. None. The mystery persists not because evidence is missing, but because the solution feels underwhelming. It's human. And we prefer magic. So how did they move 80-ton stones? Not with secret machines, not with lost technology. But with physics. Water. Geometry. Organization. And an extraordinary understanding of materials. They didn't overcome gravity. They managed it. They didn't defy nature. They worked with it. The real marvel isn't mystery. It's coordination. Tens of thousands of people. Precise planning. Seasonal labor during Nile floods. Centralized administration. Ancient Egypt wasn't primitive. It was optimized. The pyramids are not proof of forgotten supertech, they're proof of what disciplined human systems can achieve. And that might be more unsettling than aliens, because it means we've always been capable of greatness. But here's something to think about. If humans 1,500 years ago could organize projects at this scale, what are we underestimating today? What modern structures will seem impossible thousands of years from now? And here's a deeper mystery. If we understand the physics, why did pyramid building suddenly stop? If you enjoy decoding this mystery through science, watch the next video where we explore how were the pyramids aligned so perfectly to the stars, because the engineering story might be even more surprising. And I want to know your take. Do you think the real mystery was technology or human coordination? Tell me in the comments. Let's decode it together.